So class, the next section is section 3.3. And here we are talking about the addition rule of probability. So we learned that two events are independent if the outcome of one event does not affect the probability of the other event. And now we're going to learn about mutually exclusive events. So two events are mutually exclusive if they cannot occur at the same time. So here's our event diagram of our sample space. And here's event A and here's event B, and they are mutually exclusive. So an example of two mutually exclusive events would be eye color. Okay, I either have brown eyes or I have blue eyes. I don't have brown eyes and blue eyes at the same time, at least not in general. Let me see. I either live in Cary or I live in Raleigh. I can't live in both Cary and Raleigh at the same time, right? A and B are not mutually exclusive if they overlap. So this would be like having brown eyes and living in Cary. This would be all of the people with brown eyes. This would be all the people living in Cary. And in the middle here would be the people who have both brown eyes and live in Cary. So again, all of A would be the people who have brown eyes. All of B would be the people who live in Cary. And all of this in the middle are the people who have both attributes from A and B. So these are where the overlap occurs. Okay, so it could be that this is rolling a die and this is tossing a coin. The possible outcomes of rolling a die are 1, 2, 3, 4, 5, and 6. The possible outcomes of tossing a coin are heads and tails. And maybe I want to know that I get a 6 and I toss a tail. So that would be this piece in the middle. Okay, if I did both things. All right, the addition rule says that the probability that events A or B will occur, it's written like this. This is the probability of event A or event B equals the probability of A plus the probability of B minus the probability of both occurring, the probability of A and B. If they're mutually exclusive, A and B can never happen together. So this part is 0. So if they're mutually exclusive, the probability of A or B is the probability of A plus the probability of B. And this can be extended to any number of mutually exclusive events. So the probability that I have brown eyes, that I live in Cary, and that that I have brown eyes or blue eyes or green eyes would be the probability I have brown eyes plus the probability I have blue eyes plus the probability I have green eyes. Okay. And then the reason that this first formula works, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, is this is the number of people, all of these people with brown eyes, right? This is all of the people who live in Cary. And then this is the number who have brown eyes and live in Cary. So if I add all the people who have brown eyes and I add all the people who live in Cary, I need to subtract off all of the people who have both things because I've included these people twice, right? This includes all of the people who have brown eyes and also live in Cary. This includes all the people who live in Cary but also have brown eyes. So I need to subtract one of them off because the probability of A or B is this part plus this middle part plus just this part over here. So it's the people who have brown eyes who do not live in Cary plus the people who have brown eyes and do live in Cary plus the people who live in Cary and do not have brown eyes. Those are the three things that add together to give me the probability of A or B. So that's why we have to subtract off the middle piece. All right, And then I'm going to go ahead and cover section 3.4 as well. 3.4 is additional topics in probability. Actually, I'm going to stop there. And you can do the first part of your unit 2 homework 2.